A couple of months ago, I made some YouTube videos of some programmatic animations illustrating Fourier series. And one of them, this one, became quite popular, at least in my standards, with 800 thumbs up. But I think I had a couple more, like this one illustrating a lot of animations and yeah, stuff like that. And so these were built with my own library that I created called DefinedMotion. And it is of the category programmatic animation. And some of you might have seen the channel Theory1 Brown. I think it's a great channel. I mean, amazing content. And he does his graphics with his own library called Manim, which also is programmatic animations. And so this spring, I tried to learn that, and I began, I think, with the community version of it. There are two versions, his own and the community one. And when I tried it, I found a couple of features that I wish to have. And so it was primarily, I think, three. And so the first one was I would like to do programmatic animation, with all its precision and stuff like that, but also have a very strong renderer. So like supporting physics-based materials, lighting stuff, maybe even writing shaders myself, and a lot of primitives. And especially the community version didn't seem to have that. I think his own version has better 3D support, but the community version seemed quite what is it called? Like it was optimized for more mathematic stuff, and so that was the first thing that I would would like to have. And the second one was I wanted to have hot reload. So hot reload is like when you do things in the code and you save, you want to see the updates directly in the like result of the animation. And so when I tried the community version, it was like I needed to do changes and I saved, and then I needed to re-render the video and open it and scrub to the point where I wanted to see. And that was quite a long feedback loop, especially when the animations became heavier and needed longer time to render. So to have the possibility to just click save and hit hot reload the stuff and see the results directly, that would be nice. And the last thing is that while Python is great for many things, it doesn't really have good type safety. So when building larger stuff, it's like you often need to have the entire set of protocols, function arguments, types of variables and stuff in your head. You don't get much help from the compiler at compile time. It's you notice it in runtime. So when building larger scenes, having good type safety would be nice. And so I tried to build an animation library myself, and I took an approach that I think is quite efficient to accomplish those three goals. So I called it DefinedMotion, and what it is basically is that it is a library that's written in TypeScript, slash JavaScript, and it uses 3GS as its rendering backend. And many of you might be aware of what that is, but 3GS, it's a very established rendering backend which uses WebGL and soon, or maybe even right now, WebGPU as its backend. So with that, I get all the features of materials, imports of models, lighting, stuff like that, good primitives, and all the plugins it has. It just works in my animation library because it's built with 3GS as its backend. So all the community just works. So that's the first part. Then I built it, as I said, like in TypeScript, and I built it using Vite. So that gives the hot reload functionality uh, to react to changes in files, and when clicking save, it just updates the viewer. And by using TypeScript, I also get the possibility to have good type safety to build those larger systems that I mentioned. And so the one that's committed right now to GitHub is quite old. It's, yes, you can see here, 5 months. And for the last couple of days, I've been doing some work to make it better, to make it more refined for others to actually use, and to package it in CLI so you can download it much more with less friction. And yeah, so I'm gonna show you right now the most basic animation. It won't be fancy for this first one, but I wanted to show you how it works and how you can get started. This, however, will use the CLI tool, which isn't yet committed to the GitHub, but will probably be soon. So in your terminal, you can see if I can make this a bit bigger. We can go to like documents, and then you run this command, which is create DefinedMotion, and then the name, and then just some flag to make this more easy. We can call it YouTube EC1. It's the first tutorial and for YouTube video. So we run that and we get the CLI stuff copying what it needs, and it should be finished soon. And so it created this project with DefinedMotion, and it can be found here. After we have opened it, we should do npm install, and then we can do npm run dev. And so it is structured like a normal, let's say, Vite project, or maybe TypeScript projects in general. And so I'm gonna open it in VS Code like this. So now we have VS Code opened. And so the structure of the project that's copied to you when doing this CLI tool looks like this. So in the source, you will have assets where you put things, example scenes, to see how things can be done. Then we have a main, preload, and render, which are from using Electron, because the viewer, which is like a navigatable viewer, will use Electron to do stuff like calling ffmpeg and stuff like that. And then scenes is an empty folder, so you can put your scenes here. And then this is quite important, the entry. So entry is where you like decide to what scene it should point to, what it should open. And so if we do something like from the example scenes and maybe tutorials EC1, this is what we're going to build today, we can point to that. So tutorial EC1, you can see that in that project, it exports a function with that name. And so if we run this, we need to first install, like the CLI tool told us. So npm run, no, install actually. So And then we can do npm run dev. So now it had some weird scene because I didn't save this. But if I save this, then we have the easy one. And it's just some basic circle going back and forth and continuously changing its color. And so this is what we're going to build. And this viewer here, it's like navigatable, so you can move the scene around. And if I take something more advanced, like the, say, Fourier series scene, which you saw on my YouTube, if this is very heavy to run, because it has multiple Fourier series and all things should be animated, and each circle have many circles, but so I think it runs a bit slower than real time currently, but it is the animation that you saw on YouTube. And so if this is paused like so, it can be navigated to see the entire scene. So when playing, this view will be the exact representation of how the video will look, but you can navigate it when it's paused. So play again, and we see how it plays. So if we begin with this tutorial and we want to do this easy one, just now for the first one, I will create a scene in scenes, the empty one that's exposed for the user to put things in. So we can create YouTube easy one. And so when using DefinedMotion, the thing or how a scene is built is that you export a function that returns an animated scene. So export YouTube easy, or function YouTube easy1, and they should return an animated scene. And this animated scene is, at least for this example, simple examples, returned directly. So return new animated scene, and it will take some arguments to set this thing up correctly. And so the first thing will be pixels width of the video animation we want to do. And for this one, we want to do a vertical standing video. So that would be 1080 and then 1920. And the next setting it asks us for is the space setting, which is just, do we want 2D or do we want 3D? So space setting, and in this simple one we want 2 dimensions. And then we also need to set the hot reload setting. So it is the method in which it will do the hot reload. So the options here are begin from current and trace from start. So when at a specific frame and you click save, the viewer will update its content and trace to that frame to make the hot reload at the same frame. But this trace to the frame can be quite expensive. So in some cases, it doesn't really matter what is done before the frame, especially if you don't have accumulative effects and things like that. And if that's the case, we can just do the hot reload with begin from current. So it will just jump to the frame we are at and just run it from there. And even in the examples where this will not produce the correct animation, it can still be helpful to use, because it of course saves a lot of performance, but for many things, just to check if the color was right, if the sizing of some object was right, and basic things, this can still be done with the animation not being entirely correct. So just to get fast hot reload, it might sometimes be useful to use that. But for this animation, it won't be heavy and it won't really matter. But we can use the from tracing from the beginning, so we can be confident that it's always rendering the animation exactly like it should be. And the last argument is actually a callback function. So we give a callback function where we will take an argument, and this will be the DefinedMotion scene. So we can call it DM scene, maybe. It's, you can call it whatever you want, but so now we are ready to build the animation, and we can begin by making our entry point to this scene. So YouTube easy1, and we can do run our application, save our animation, and it's just currently white because it it doesn't add anything to the scene, and it doesn't do anything. So we can begin by doing a just plain circle. So const circle equals to create circle, and we can give it a radius of 5. And then we want to add this circle to the scene, so we can say scene, or we actually call it DM scene, add circle. And what's next to do is like to make this I restarted the application to give it, let's see, so you can see it. You need to have it like here, maybe. You also should see the code, maybe like that. So here we have our circle, and we wanted to animate back and forth. So we want to create an animation, and from tutorials, the easiest way to create an animation in this case is to use this. So I will be so lazy that I will actually copy it. And so this uses create anim, and this is just a function that takes an interpolation. So an interpolation in DefinedMotion is just a list of numbers for like values at each frame of the interpolation, and we will use a is in out quad that DefinedMotion exposes. So this says like create, as you can see here, it returns a number list. So the interpolation is just actually just a static list that's returned at one time at build time. So it's nothing magic about it, and you can easily build your own interpolations. So this one will go from -5 to 5 during time of 500 milliseconds, and it will just produce the number list that is that interpolation. So if we look at this, it will start to convert the duration, which was 500 milliseconds in our case, to the number of frames, and then it will just do the basic quad is in out quad interpolation of that and return it. So that's like a static calculated thing. And then our create anim will take a callback function, and this just says for each value, for each value in this interpolation, the scheduler will call this callback function with the current value in the interpolation, and then you can do whatever. So you give the function to do whatever with the value. And here we want to say that we take the value at the current, frame of the interpolation, and we set the circle X position to that value. And so then we have our animation, and we use this create animation to build the final structure. It should be a user animation, as you can see. And then we do dm scene add anim and our animation. And then we should see, when we click play here, this should be 500 milliseconds long, and it should move from left to right with an is in out quad interpolation. Yeah, and you can see it restarts over and over again, but for each iteration you can see that it does exactly this. But to make this look smooth, we would like to do the animation, but then reverse the animation, exactly the same but mirrored. So a nice way to do that in DefinedMotion is to add an animation again, but we haven't created a new animation. But actually, in this case, when we just want it reversed, it's quite easy to do that. So we can do copy, so we don't manipulate the original instance of the anim, and then we do reverse of that. So now we have added first the anim, and then after the anim has run, we add the reverse of it. So, which means it goes back and forth smoothly, and of course it restarts, but it will restart at the same place. So now we have built that, and the final thing to do to make the continuous color change of the circle, then we use a very nice thing that's I think very convenient to use in DefinedMotion, and that is that we can just expose a function that will run globally on each tick of the animation. So dm scene on each tick, and then we can take the tick, but we can also take some other things. In here, we have a callback function that will be called on each frame of the animation. It won't push or make the animations any longer. It won't add, interpolations or any of that stuff. It just says that for the animation that is built, on each frame that's run, call this function. And this means that we can just create dependencies. If we have like two circles that move around and we want to have them connected, we can just say that the animations move the circles, but we have the on each tick dependency that make sure to move the line endpoints to the centers of the circles to make them connected always. And so expressing dependencies is very trivial with this. And so for this case, we want to change the color, and that can be done with many in many different ways. And remember, we always have all 3GS properties to access. So if you don't want to create a circle with the exposed function to create a circle, because the default function isn't even that flexible, you can just make a circle by using 3GS primitives directly. So that means that even if DefinedMotion hasn't something built already for the things you want to do, you can always use 3GS primitives directly, which is very powerful. So we can copy the line here from the tutorial. So if we go, and we also need to import 3GS, because now we are calling 3GS stuff. So that should be just this line. So I can see if I can make this a bit more. All right, so we have the circle, and we did create the circle with DefinedMotion exposed function, but that in turn will just return a 3GS primitive. So all its exposed properties like material and stuff like that will still be there. So we can access the material and then color and then set it to a 3 color. And then we want the color to continuously change when the circle moves. So in some way it needs to be calculated depending on the X position of the circle. And so we, for each frame, set the RGB color, and we do that here. And for the G and B values, we just set it to 1. But for the R, we make a little function that changes it how we wanted. So DefinedMotion exposes positive sigmoid function that could be used to avoid negative values. And it was quite fitting here, but you can just write your own math to figure out the color you want. So with this, we have added the circle here. We have created an animation with this which is just this static calculated interpolation and the callback function. We have added that animation and also added a copy that is reversed, so it will go doop or doop. And then for each tick in this animation, this function will be called this, which we gave here, and it will set the color. So if we save this, you can see it updates instantly here because we have hot reload. And if we play it, it changes the color, continuously, exactly like we wanted. And that is the entire tutorial one. I can show one single last thing is that maybe if I do put this on like the last coordinate of the color as well and click save now or now, you can see it change the color. Just to show the hot reload feature. And yeah, now we have another interpolation. We could set a different like division here. So yeah, that was about it for the first tutorial. And I think this shows some powerful features with DefinedMotion. And yeah, thank you for watching.